Welcome to another video for General Science. In this video we're going to be discussing Newton's second law of motion, which you can see is exhibited in your formula down below. Acceleration equals force divided by mass. So the acceleration of an object is equal to the net force acting on it divided by the object's mass. So this formula is probably more familiar to you in this form: force equals mass times acceleration. Okay, so how do I derive acceleration equals force divided by mass? Well, simply, just some simple algebra. I can eliminate the term mass by dividing by mass on the right side, and whatever you do to one side of the equation you must do to the other, so I divide by mass, and I end up with acceleration by itself on the right side. And that's actually how I derive the formula that you see in the very beginning. And it's the same thing. Force equals mass times acceleration, or acceleration equals force divided by mass. It's derived from the same root formula. So you'll notice that force equals, it's the same thing as your net force divided by mass. Okay, so these terms are one and the same. Okay, so let's take a look at an example in real world to see how this applies. So an automobile with a mass of 1,000 kilograms accelerates when the traffic light turns green. If the net force on the car is 4,000 newtons, what is the car's acceleration? So one of the first things you want to do when you have word problems is you want to read these very carefully and understand what exactly is going on. Once you understand what's going on, try to identify the givens. Okay, so I look at my formula and I look at what the problem is giving me. It's giving me mass in kilograms. So I know that my m is covered, and I also know that my force is being given. So once I find or I identify my givens in my word problem with my equation, I can now just plug them in, plug and chug as we refer to it in class. And at this point, once I put them in, now I can just do my arithmetic and I end up with 4. If you were to put this down on your paper, you would get partial credit only though, because one of the things that you're missing, which is essential, is the units. Okay, so I'm going to show you how we derive the units for acceleration from this particular formula. So your force, you know, equals kilograms times meter per second squared, right? And then your mass, of course, you know, is kilograms. So this equation is essentially force divided by mass, which is kilograms meter per second squared divided by kilogram. Okay? So if you recall your rules of multiplication for fractions, you don't really technically ever divide a fraction so much as you multiply it by its reciprocal. And here I have that case. And once I have a multiplication set up, I can now just multiply it straight through. And you'll notice here that I have two terms that I can actually cancel out, which are my kilograms. Once I've canceled out my kilograms, on the right side, you'll notice that it's basically a 1 over 1, which is 1. And you multiply meters per second squared by 1, giving you meters per second squared. And that, of course, you recognize as acceleration. And that's how I derive our units from our formula. It actually works out perfectly every time. So now I have a completed term or answer. My acceleration is 4 meters per second squared. So my car, once the light turns green, is accelerating at a rate of 4 meters per second squared. All right, let's take a look at another example here with a helicopter. Here you have a helicopter, its weight pushing it down. Okay, so it's keeping it grounded. And its propellers, as they're increasing in speed, they're creating an upward force that pushes a helicopter up. It's enough force to overcome the downward force of the weight of the helicopter. And now you're seeing the helicopter accelerate in an upward position or an upward direction. That's called lift. Okay, so let's take a look at our helicopter example. What is the upward acceleration of a helicopter with a mass of 5,000 kilograms if the force is 10,000 newtons? The upward force is 10,000 newtons. So again, I identify my givens. Force is in 10,000 newtons. My mass, 5,000 kilograms. And now I can just do my arithmetic, and I know I end up with 2 meters per second squared. So my helicopter is accelerating in an upward direction at 2 meters per second squared. So before I conclude this video, I want to show you from a mathematical perspective how this ratio of force over mass works out. Okay, so if I take my force over mass ratio and just put it in mathematical terms at 1 over 1. What happens, notice in my numerator position, what happens when the number increases? What happens to the overall number? So I'm assuming now that the denominator remains constant. Now, as the numerator increases, you notice that the overall number itself increases, right? So if I compare from 1 over 1, 2 over 1 I know is 2, 3 over 1 is 3, and so forth. So my number is actually increasing. So if I take that idea of how numbers can increase based off of how the numerator increases, I apply that to my physics problem. If my force, which is in the numerator position, increases, then my acceleration also increases, my overall number. And if you think about it, it makes sense, because if I'm pushing an object that's the same mass, that the mass remains constant, and I apply more and more force every second, as my force, my numerator grows, the overall acceleration will grow. Because if I push something soft and I keep pushing it even harder, then I'm going to accelerate it. Okay, so now let's take a look at that same idea, but now let's flip it and look at the denominator position. What happens to my number as my denominator increases in size? Well, let's go back to 1 over 1. 1 over 1 you know is 1. 1 over 2 is half. 0.3. 0.25. 0.2. So you'll notice that my overall number, as my denominator increases in magnitude, the overall number decreases. So if I take that idea that if the denominator increases, I'm actually approaching 0 as that denominator increases. If I apply that idea now to my physics problem, if my mass increases, my acceleration will decrease. And again, if you apply that to a real world, it makes sense, because if I'm pushing something, if my force is constant, but I keep adding more and more mass to it, it makes sense that as I keep adding more mass, then it's going to be harder to push, causing a deceleration. It's causing my acceleration to decrease. Well, my hope is that approaching this ratio of force over mass, approaching it from a mathematical perspective, and in you seeing the relationship between the math and just a general idea of how motion works, that it makes it easier to understand this concept. Okay, so again, as my denominator increases, my overall number becomes smaller and approaches 0. Well, that does it for Newton's second law of motion. Thank you for watching, and good luck in your studying.